Hello, YouTubers. This is another special session where we get to talk to amazing engineers everywhere that have amazing ideas. This series specifically is dedicated to exploring existing projects out there or projects that are at its inception with some of the most amazing engineers I had the honor to work with, and see where these projects are headed, get inspired by their ideas and hopefully we can even help the person that's building that project actually make it even better, bigger and better. So I have my guest here is someone you might have seen on my channel very often, Mr. Joe. How are you, Joe?
I'm doing good. Just got back from a walk with my daughter. She's napping. It's quiet. We're good to go.
The perfect trifecta. That's the formula. You got three moons lined up.
Yep.
So tell me a little bit about what you're trying to build here, and tell me, the backstory. This is your time. Tell me everything you have. Go ahead.
Yeah. So it's probably going on a week or 2 weeks now since I
Right.
seen an example of a pattern that you implemented, the removed try catch
Yeah.
operations, and I was thinking of a way to possibly clean that up, remove some noise,
Yeah.
and make it fluent. So
Yeah.
when you go and review that code, everything that you need to know is right there, possibly on one or two lines, and then you
Yeah.
can move on. So it
Nice.
started off with just the try catch concept, and then I decided to move it into kind of wrapping just general flow control concepts. Switch statement
Nice.
is the next example I put in here.
Nice.
My focus is to use this as an opportunity to apply the standard and progress that way. I'm very light on the knowledge in that regard, and I'm hoping to learn a lot. And I'm
Awesome.
hoping everyone else can learn as well by reviewing these videos afterwards.
I love it. I love it. So just for the people watching this for the first time, um, the pattern that Joe's talking about, something that I call exception noise cancellation. What that pattern says, just in short, is that if you have a system of any kind, and this system is basically you need to handle some exceptions there. Let's pick up an example of a project here and just walk you real quick through it. Let's pick up OData Neo, for example, the work that we've been doing. In any project, if you're building something that's industrial, something that is supposed to withstand, any changes, something that is ready to have other projects and other components built on top of it. We want to make sure that the foundation is solid. I literally call it foundation services because they're the ingredients or the primitive operations that you can build everything on top of. So from that perspective, if you look at here's OData Neo, here's the project. If you look in here, you could have a situation where on the service level itself, right, you have a function like this, and then there's little try catch guy. This little try catch guy saves us from having to have the code looking like this. Let me show you what the code would look like without a try catch in here. So, the code would look something like this. And this would be we don't need this guy, we don't need this guy, and we don't need this guy either. So the code would look like this. You would have a try catch in here, and this try catch would be literally everything that we have in this area here. So so imagine this side here, or you could have this entire side sitting over here to handle all of these exceptions. See, so imagine like if you're handling five or six different other exceptions, your method continues to grow like this and becomes really, really hard to focus on the real business logic, that's behind the code. And like I always say, like in object-oriented programming, objects are meant to be 3D. They're supposed to have different aspects. And it seems like so far what I've seen in the tech industry is that we're building these objects in the 2D space. We put everything right in front of you like that, and then it becomes really hard to understand the code and really hard to read it. So, so Joe, do you want to show us okay, before that, here's the try catch. If you want to see what it's like, we do a delegate. We pass that delegate in here, and then we go call that delegate. I don't know why we have this guy. We don't need that guy. But we have that delegate in here, and basically that delegate is where we pass a function to a function, and then this function gets executed. And then we handle the exceptions that come out of this particular function. Just very sweet and simple. It's living in its own little partial class on the side, so you don't have to worry about, exceptions unless you're looking for them. You're actually going and looking specifically to look at that aspect, of your object as a service. Okay, Joe, what you want to show us what is the innovative idea that you have from your side. By the way, I saw some of the stuff that he's doing. It's actually pretty cool. It looks really sweet. We just need to see how far he can take it. Let's go. Hmm.
Yeah, let me share my screen. Oh, we got the matrix going on now. Let me move it.
Hmm.
Screen one, share.
There we go.
All right. So, one other benefit that I didn't realize until just now is it also cleans up your using statements. I didn't notice it until you copied and pasted your catch
Yep.
block.
Yep.
So when you open up that business logic source file, those using statements at the top are only for your business logic. You don't get to see the other ones until you go into that particular
Nice.
class.
Nice.
So I'm going to shrink a bunch of these up because those are um, kind of extension points or areas that we're not ready to discuss yet.
Okay.
So the try catch, let's just work on the action one for right now.
Okay.
So I should probably just make an example.
All right.
Let's go to the test. That's probably the best one.
Yep.
So in this case, let's see, where do I want to start? So yeah, this is a good one. So
Hmm.
in this case, I just wanted to, this stuff's actually a little harder when I give you credit for being able to do your explanations on the fly. It takes me a little more thought processing to get that part done.
That's
Um,
okay.
so like
I
I'm
mean, I was just telling someone this the other day. I was telling them, he said, I turn, I get a little nervous or I'm trying to explain things to people, and I said to them, well, you're not streaming 50,000 videos every day. So, I don't expect people to kind of, please take your time. It's all right. We're here. We're looking at it. We'll see how it looks like.
yeah, I just want to add a couple more. I want to show off the fluentness and a couple more examples. So let me do that real quick, and that should be good to get the idea across.
Okay.
All right. So, what were you saying with you were working with someone else?
Yeah, he was just getting nervous, when we tries to explain things. Like I've been begging some people to come on the show like this and kind of talk about, their stuff, but they get a little um, you know, uneasy with it. I really appreciate you coming in and kind of saying, here's my implementation, here's what I think.
Yeah. So this is a learning experience for me, just because I got to get through this process of being able to
Yes.
do these types of things. So,
Yep.
um, I just figured I'd set this one up kind of like what you would see in real life, like not implemented. We could do. Um, I don't have this namespace, but we'll add it real quick.
Uh-huh.
Here, I'll just debug. Debug.
Debub.
Yeah.
It sounds like a new library name. Debub.
Yeah. Yeah, there we go. I installed the GitHub Copilot. It's scary. I'm getting used to it. I don't always agree with everything. I end up deleting almost everything it gives me, but it's just good because it's another example of something you might want to go down um, in that in kind of like pair programming.
Yep.
Um, I think I'll just copy this and this gets the idea across.
Okay.
And then throw new, that works. Okay.
Okay.
So basically, in Hassan's example, where you have the try catch off the screen, it would probably end up going to something like this instead of
Mm-hmm.
having the whole try catch. So it even simplifies it even more. So that
Nice.
was my idea originally.
Mm-hmm.
Um, so I guess we could. This is the example usage. We could dive into maybe like what I did to get this working, and then
I have a question for you first.
yes.
Like you're passing, so zoom in a little bit, Joe, just for the people on their phones to be able to see, zoom the,
Oh, I
zo-
know. I figured out why I can't zoom. Let me go fix that real quick.
okay.
And yeah, um, I forget what the name of this extension was. Right there, tweaks and zoom.
Nice. Okay.
And it still don't work, but let's just do it manually. Sorry,
Yeah.
200.
Okay. So let's take a look at this closely. You're basically saying,
Yeah,
so
I
you
just
have a function, right? And this function, that's the action that you have, right?
yep.
That does it. So okay, so you're passing Flapper. Flapper is the library name, and you're basically going and saying, here's try catch. Put that in a try catch encapsulation. And then whatever comes back, you can add on top of it. I want to catch this and this and that. Love it. This is like an extension method, that
Yeah,
basically,
sort of. Except for we have to have some context that we pass through them, so that's why this guy has to be instantiated. I
okay.
was working on this guy here, which
Hmm.
would allow you to just work right off your execute. So let's go show that example.
Nice. Nice.
So now your method's just passed in, and you don't even have to worry about the flapper part.
Wow.
So
Nice.
there is some magic around that because I wanted two-way translation.
Yeah.
Um, so if I actually go to flapper, we have two implicit operations here. So flapper to action, action to flapper, and
Hmm.
then for any need for returning of a, a, a value, that's why I went with the func version. So,
Hmm.
unfortunately, because delegate doesn't explain anything about its arguments or return type without having to get into reflection,
Hmm.
I just basically support action and func and
Hmm.
purely for the sake of return types.
Nice.
So,
Nice.
that
I,
that
I mean, eventually can support value task and stuff like that,
yeah.
but that's
So
just,
that's what our discussion will hopefully evolve into.
yep.
That and the community. So I'm looking to probably open this up very shortly.
Okay.
Um, I threw an MIT license on it just because
Nice. Nice.
anyone can play with it as
Yep.
long as they don't steal it for themselves or
Yep.
whatnot.
Yep.
But why don't we go take a look at the implementation, and then I'm a little light on how to proceed from
Hmm.
this point on, so I might lean on you for that.
Yeah.
So,
Yeah. Yeah.
okay.
Yeah. Hmm.
So basically, I got to thinking of what a try catch really could be broken down into.
Hmm.
And I basically collapsed it to a dictionary of this is the func one. Let me go to action,
Okay.
which I broke with the. Let me undo all this so that.
Okay. I think it's because you copied the same test name. That's why
Yeah.
you could just undo. Yeah.
Bam. Okay. So action up here, try catch, action. Okay. So back up here. So we got our dictionary.
Hmm.
It matches a type to an action of exception. That way we can handle this type is the actual exception being thrown,
Hmm.
and the action is the handler. So try catch flapper needs this would be the business logic that you're passing in.
Hmm.
What gets executed in the try. And then the catch just basically returns this object as well as add the handler to my dictionary. And
Nice.
then I have to expose some form of execute method. So I did
Hmm.
that with an override because this has a base method. We'll look after this.
Hmm.
So this execute method will execute the try catch as well as the business logic. So we can do that here.
Nice.
As far as testing goes, this little guy here is meant to allow something like your internal mock
Hmm.
package to basically inject instability if we want to go that route. So I allow that here. So
Hmm.
basically, all this does is execute the action.
Right.
Which using internal mock, you can just replace this. You can have it be whatever you want.
Hmm.
And then I do the same thing with the handler. So if you want to actually inject instability in an individual handler, you can do that too.
Nice.
Um, so the
What?
try get handler, so we're back up here again. So if an exception happens, I try and get a handler. If one exists, it'll come out of this methodology or this try get
Yeah.
method.
Yeah.
If not, I just throw because
Nice.
we're not. I wanted to keep with standard
Yep.
.NET
Yep.
exception handling
Yep.
practices. So we
Yep.
just throw just like there wasn't a handler for it in the first place. And then we call the invoke handler. So it's pretty simple. I just had to kind of get to the core of what try catch was actually doing,
Yep.
and basically some of our discussion that ODAT and Neo
Yep.
with ODAT and Neo is kind of like expressions and everything. So I actually went and looked at like how the like there's a try body and there's catch bodies and stuff like that. So I kind of wanted to mirror that, but
Yep.
in the delegate space rather than expressions.
Nice. Nice. I
um,
love it.
and
Yeah.
then the implicit stuff. So that's basically the gist of it. The only difference between this and the Funk version is we use Funk with a T result rather than action everywhere. All right, so now we can actually go to the base class because that's what helps any existing flapper
Yep.
to work. I chose the name Flapper. It's a merging of Fluent
Yep.
wrapper. So
Yep.
my naming might not be the best or
I
branding,
like that name.
but it works for me. So we'll go there. Basically, this is the action version,
Hmm.
so it takes in an action versus a
Hmm.
funk. Um, Null handling, and so this follows the same practice. If you want to override this using internal mock, we can do that. And
Hmm.
then same thing down here. We got the implicit operators so that an action can go to a flapper can go to an action, and now you can start nesting flappers inside of each other without having to worry about casting and stuff.
Got
So,
it. Got it.
but that's pretty much the magic. I did start working on the switch flapper yesterday morning, and I was able to get a few things in here for that. So this is the first time anyone else other than me's looked at this bit of code. So why don't I show that off, and then
Yeah.
basically we can do Q&A with each other to see where we go
Yeah.
next.
Absolutely.
So switch flapper action. So this guy here, unlike a try catch, is specifically for flow control, right? You choose a path to execute and then continue on.
Hmm.
So in this case, I had to make a new type, which is each case that this flapper is going to handle.
Hmm.
And then I need to provide because you switch on something, right? There's a
Hmm.
value that is your key for determining that path.
Hmm.
So
Hmm.
we take in the value, and this is kind of unique for this one. We have to have a default handler. I actually allow this to be ignored,
Hmm.
in which case I do a no operation default handler because I
Nice.
need to execute something to proceed. This no operation basically is what it sounds like. It's a static void, do nothing.
Nice.
Same thing, we can inject instability here if we want to. And let me go back up. So basically, we get our list of handlers. Because there's no lookup needed, I chose list.
Yep.
And same case as before. We have a handler collection. We add a new switch case. I chose this
Oh, you're doing it
to
even for switch
match
case. Mm-hmm.
the
Mm-hmm.
standard switch in .NET.
Mm-hmm.
This won't mirror any pattern matching or anything.
Mm-hmm.
We'll get to that in a moment. So this purely checks out equality. So let's take a look at iSwitch case real quick. So there's a satisfies case
Mm-hmm.
functionality. It returns a bool, either it's going to work or it's not. And
Mm-hmm.
then there's the action handler. So that's that. The the actual switch case, the satisfies case, is just purely an equals operation, just like a
Mm-hmm.
standard switch.
Mm-hmm.
And then it has the action as a property.
Okay.
All right. The next one is to handle the pattern matching. This one I had to think about a little bit. So basically, we're going to take in a func, which
Mm-hmm.
is basically what that pattern matching is behind the scenes, anyways. So this one here, it's relatively simple. You just stuff the func into a read only and execute it when you need to.
Nice.
Yep.
Nice.
So the execute, we try and get our handler. We go through our handlers, first or default, that satisfies the case. So just like a standard switch
Mm-hmm.
is the first one that matches, we're going to execute that and exit. We'll have to, because switch does have, what is it, fall through, or
Yep, and
so
default
we'll
and
have to figure
continue.
that part out. I think we can do it. We could definitely do it. I
Yep.
just don't know how to yet. So we'll figure that out. But anyways, if we get a potential handler, if that's null, then I return default here, and then say we don't have anything. And then
Nice.
if we do have one, I just return its handler, which is just going to be an action. We're not executing it yet. That is going to happen here. So we get our handler out. If we didn't get a handler, we'll execute our base, which is going to be the default
Mm-hmm.
case.
Nice.
Same
Nice.
thing in oh, I missed. So this one right here, you remember in the try catch where I
Yep.
had, yeah. So this one here is not interceptable, so we'll have to add that.
Yep. Yep.
So that was something I missed. So good thing I review this stuff with you guys, because I find things that I
Well,
hope someone out in production doesn't find, right? It's better to
yep.
find it before it gets out there.
Yep.
So
Yep.
same
That's the whole
thing. I
point.
mean, this is relatively simple code for wrapping a simple idea and using it in a simple way.
Mm-hmm.
The thing is, it's the idea of it is the complex part. It's just coming up with how to break it down into its simplest form. That seems to
Yep.
be the most difficult part for anyone. So that's basically it. I do have
Mm.
no, that's it. So I broke this out into a bunch of individual packages, so you can
Packages. Mm-hmm.
consume which one you want to use. You don't have to consume them all.
Right.
Pie in the Sky will have a one of those NuGet packages that will just bring everything in for anyone that's looking to experiment with multiple parts at a time.
Right.
So that'll come down the road. Um, so let me just stop double clicking on stuff, and then
Mm-hmm.
so we have our flapper for actions. I'll just scroll through that real quick. So very simple. The flapper for functions, same thing, very simple. And all these do is expose the business logic to any flapper that would be inherited from these.
Mm-hmm. Mm-hmm.
I do have a test helper. This here, I may or may not ship. Basically, it does what your internal mock is going to do, but specifically for this set of libraries. So the only thing that this would do that your internal mock would be expose the internal methods to whatever testing system you want to use it in. So probably we'll do like flappers, try catch test helpers, and then the only thing you would end up having to do, it would be add instability and
Mm-hmm.
then pass it whatever test function you want to to replace
Nice.
the actual one with. Um, and
This
then
is this is even test friendly, like you're
yeah, well that
basically
was I wrote this part before any other part. I
that's a
wanted this to be test
beautiful,
friendly from the start.
yeah.
I keep looking over because that's where you are. Let me move over here so I don't look like I'm staring off in the corner.
Okay,
This
just
doesn't work.
it's not gonna work.
No. Okay, we'll just do this. Okay.
So, so, so let me tell you what I love about this, you know. First of all, the language is perfect. You're adding instability. You're
Yeah.
attaching a problem into your existing routine, and you're trying to shake up that routine to kind of cause, oh man, I like that a lot.
Yeah.
Um, nice, nice. And then you could basically go and say, well, here's your entire because, see, that's the thing. In the .NET world, exception handling is one of the least visited part. You know, people just say, "Oh, catch exception, throw." Don't even think about it. You know, let go, trying to dig deeper and dissect the issues that could happen, and make sure you're handling them properly. This gives a whole new perspective and a very, kind of sheds a very interesting light on the possibilities there. You can even take it further and simplify things.
Well,
Y-
let me just come over here to try catch. I where this isn't where it is going to live, but because of dependencies, it's easiest to add here.
hmm
So like the try catch. Um, I wish this was faster. There we go.
hmm
So let's come back over here. We'll just grab this one here. Memory detour. I'm not going to worry about that. I'm just going to.
hmm
All right, that's good. Oh, that doesn't exist here.
hmm
So basically, the whole purpose for my demonstration here is to show that when you get these test helpers focused on a particular flapper, you can actually remove like the this type, and that's basically it. And then since we remove the flapper type, we can just say that this is
Yeah,
that, and semicolon. There we go. Forgot what I was typing for a minute.
hmm
So with that, we can now do add instability, give it a better name, and the consumer of this no longer needs to know about the internal method name,
hmm
stuff like that. So you can make this extremely focused, where the end consumer of
hmm
this basically, I would like to get away from the types. Like you could
hmm
do um, like something, and then get
Yeah,
rid of that, and basically get down to something like this.
you can now say, okay, the type of whatever that
Yep.
is. Yeah,
So things like that
nice,
will definitely help when we get to that point.
nice, nice.
My
hmm
my first prototype of this is what I did, and then I decided that this test helper shouldn't even be in the same package,
Yeah,
because now we're bringing in all
much
these
more than
dependencies
what you
that we
need.
don't need.
Yeah,
It's too much
yeah,
noise. Yeah.
yeah.
So, but yeah, so that's about as much as I think we need to go through. It's not like once you see it, once you kind of get explained to the purpose and the reasoning and see what I'm actually doing,
hmm
it's not rocket science. Like
It
we
it's
just
it's
start,
it's just it's just
yeah,
kind of it's making the code much better and much easier to test and understand.
yeah,
You basically you basically handled two big issues, right? simplifying try-catch, exception handling, abstracting it away from the code so people can still focus on the logic. But now you're making it more functional, which I really love. You're
Yeah.
making it functional. So, don't worry about this whole scoping and all that kind of stuff. Don't worry about none of that. But there's also something more in here. Let me tell you the need, this library exactly fulfills that. So sometimes more often than ever, we can't just go and say just how exceptions are built. First of all, okay, so number one thing I love about this is that you're making it functional. So the code itself can shrink, dramatically, right? Because if you look at let me show you let me show you a Git file while we're at it. Just show you the exception handling that happens in there. If you look at any particular uh, um, orchestration service or a coordination service, right? Things get a little busy, right? Because you have all these different exceptions, and you may or may not be able to handle the same exceptions the same way, right? So you may or may not be able to go and say, I want to, let me show you here. So I want to be able to, let's pick up a let's pick up an external contribution service, not this one. I want to pick up an orchestration service. So here is foundations, profiles, orchestrations, exceptions. Check this out. So in an orchestration service, this is real. This is the real world issues that can occur from a particular orchestration service. Look how many exceptions that can be handled. It's a lot of these. you know just for the people watching us to understand, this is not an open source project yet, right? But this is the real life, right? Yeah, you're going to end up with a situation where you have all these exceptions. Now, where does your library come in handy? Look at these guys, this guy and this guy and this guy and this guy and these two guys as well. These are 6 different occurrences that are handled exactly the same. If I were to be able to go and say, or the exception was this, or it was this, or it was this, I would shrink all of that in one place. See what I'm saying? So that's one part where I think Flapper can actually help a lot, because now we control how we can represent this. You can go and say catch, and you can in the catch method, you can basically handle multiple. You could pass a params in there, and you can throw as many exceptions that you want, and it will be handled exactly the same way. That's genius. I love that. I love that. The other thing is okay, so you did the action based and then multiple exceptions handling across, in a larger orchestration services. That's beautiful. And then the third thing that I'm seeing here is traceability, right? I want to be able to, like, I'm about to just, maybe today, maybe in a couple of weeks, depends on the mood, I'm about to introduce trace, right? And tracing, today, we only log when there's an issue. I also want to give people the opportunity to see what it's like to trace a problem, which is another aspect that gets added to every service and stuff like that. I think with Flapper, I think the traceability aspect of it will be a little bit easier, because you could just inject your logging broker somewhere, and you could go and say this is for traceability, like trace all the operations, going on in here. Just for the people watching, tracing is when you log an activity even if there is no error. So you're basically saying at this hour, this particular method was called with these particular parameters, right? And here's whatever comes after that. That helps you kind of draw a timeline of what actually happened from the moment an exception was received in a particular RESTful API endpoint, all the way until it got served and processed, or it errored out. It's one or the other, right? Or partially served and partially errored out, like I was explaining to Joshua the other day about the 206. The 206 error is partial result. Sometimes there is this quantum state where some pieces fail and some pieces succeed, and you still respond to your user with a 200 code. So what do you think about that? Do you think these things are possible to implement, like handling multiple exceptions exactly the same way without having to repeat the code. Because today we repeat the code. Today we go and say for file profile event processing dependency exception, create unlock dependency exception, and then for another situation, profile event processing service exception, create unlock dependency exception. We want to be able to kind of minimize and simplify that. What do you think about that?
So right off the bat, after hearing you talk, there's two ways of handling it in the code base right now.
Mm-hmm.
Either we can borrow from the switch implementation where we
Mm-hmm.
do has an is satisfy,
Mm-hmm.
or inside of the function for registering a catch,
Mm-hmm.
we can just do like what you said earlier, have a params, and inside that function just iterate over the params and keep adding handlers. Like
Mm-hmm.
I like right here, this is probably an extreme catch case for
Yep.
a
If
lot of
you're
scenarios.
if you're doing a
I
catch and you have multiple dependencies like this, yeah,
Yeah,
you're gonna run into a scenario like that. Go ahead. Go ahead.
yeah. So we would have to do some profiling to performance profiling to see where at what point will this library start being too memory intensive and stuff like that. So
Mm-hmm. Mm-hmm.
I built the dictionary portion to handle this with the explicit knowledge that I probably would use max 10 in my day to day.
Mm-hmm.
And past that, we might want to look at another backend storage if it becomes intensive, if you will. I doubt it'll be a big deal.
Yeah.
Um, the other option would be to make our own um, collection system that's based off struct or something so that we're just not allocating a whole lot.
Mm-hmm.
So we can go down that path. But yeah,
Absolutely.
as far as the multiple handling, I think that could be handled pretty quickly with two of those scenarios that I just thought of. The
Awesome.
easiest
Awesome.
right now would be the loop.
Yeah, yeah, absolutely. Is there anything else you want to add in this library for the future, like your ideal state, to kind of get this library in a place where you say, yeah, it is at a good beta state that it can actually be, implemented and used, integrated into standard compliant projects. What do you think? Mm.
I'm sorry, I'm not sure if I followed what you were saying.
Like usually when I build libraries, like for instance, this internal mock library, right?
Yeah.
I'm handling exactly the scenario that I need. But what I want in the future is that I want to be able to also mock a return value, right? It's not just throwing an exception. I also want to do a return value. And then someone came in the other day and says, you should make it a functional expression. And somehow I want to figure out a way to expose what is supposed to be a private method, right? So somehow I'm looping over a dictionary that pulls in all the private methods that are available, so I can just go and say service fat arrow service dot, and then it shows the method name. Even though it's private, it's not exposed by default, but we can make it, through that kind of iteration. So what's the ideal state? What's your future thoughts? What do you want to implement in this library other than what you have today? Is this your ideal state? Is this a thing have you given you may or may not have given it a little bit of thought to just think about the possibilities, right? Because that's your world. You can do
Yeah.
whatever you want in there. Go ahead. Go ahead.
So originally when I the try catch was like the origin. When I saw your example, I was like, oh, I can make this even cleaner. So I went and did that. That was the first example. I believe I shared it on ODAD
Yep.
and now.
Yep. In the
And
standard community.
oh,
Yep.
you actually replied. You thought the catch portion was something you didn't think of yet.
Yep.
So I thought, oh wow, I might just turn this into a library now. So
Yep.
I did that, which now I got to delete because the whole thing is different now. So,
Right.
yeah, I think right now I would say this is good for an alpha or beta release, and
Hmm.
then going standard compliant. Um, Unfortunately, I haven't gone through all your videos, and my chatting
Have to
with
go
people
on.
that are standard compliant has been very light.
Yep.
I believe that Mabruk is very
Mabruk.
interested in also checking this library out and possibly contributing. So I think with I think this is in a good state to open up and just allow people to either start using it as is or contributing as is.
I love it. I love it. If you decide to do so, I'll put the link in the description of the video. I want everyone out there to just take a look at this. This is us actually giving care and attention to a very, kind of seldom or rarely visited side in the .NET world when you're trying to handle particular exceptions properly and use them as a part of your flow control to kind of make sure how things are going in case of errors. Joe, thank you so much very much for, Joe and I have, we've been chasing each other, right? It's been a week. It's like, okay, let's do it Thursday. Let's do it Friday. Oh my God, sorry, I have a meeting. Oh, I can't do, I'm already out, and all that kind of stuff. So I'm very glad that we actually found the time for each other to talk about this. Of course, as usual, Joe is in the standard community. If you have any comments, you want to talk to Joe directly, you want to, kind of discuss with him what is the need and how he implemented that, or you have ideas, either go to his repository, create issues, or create pull requests, or just join us in the standard community. I'll drop the link in there. Take a look and see what we're doing. There's a lot of really, really smart people in there, and they have a very, very good sense of humor. So, if you don't get, something new that you learn out of it, you're gonna get a little laugh, or just get a new friend, which is great. Thank you so much, Joe. I appreciate you. All right. All right. And for the people watching us, of course, if you have any questions, comments, concerns, drop a comment in the comment section. And don't forget to like and subscribe. See you guys later. Thank you, Joe. Bye.
Bye, everyone.
Bye.